Hey engineers, welcome back. In the last video, we got comfortable with the AutoCAD interface where everything is how to move around. Today we need to cover something boring, but it's actually really very important. Units. Look, I'm not going to sugarcoat it. This isn't the most exciting topic. But here is why you need to pay attention. If you skip this step or get it wrong, everything you draw after that become a mess. Your dimension won't make sense, things won't scale properly, and you'll end up redoing work. I have seen many people spend hours on drawing only to realize their walls are showing up as 10 feet thick instead of 10 inches. Not fun. So let's spend next few minutes getting this right, and then you'll never have to worry about it again. Sound good? Let's go. First, you need to understand something about how AutoCAD actually works. When you draw a line and you type the number 100, AutoCAD just stores that as 100 units. That's it. It doesn't know if you meant 100 millimeters, 100 inches, 100 feet, or 100 miles. AutoCAD is completely unitless. It just deals with numbers. Think about like this. If I tell you to cut a piece of wood to length 5, you do ask me 5 what? 5 inches or 5 feet, right? You need to know the unit. Same thing is here. Look at this rectangle. Is it 10 millimeter wide or 10 meters wide? To AutoCAD, it's just 10 units. The software genuinely doesn't care. But you care. Because when you print this or when you dimension it, or when you send it to someone to actually build something, those numbers need to mean something real. That's what we are doing today. We are telling AutoCAD, when I type numbers, here is what those numbers actually mean. Once you set this up correctly at the start, everything else just work. Dimensions show up right, blocks come in at the right size, scaling makes sense. Skip this step and you are constantly fighting the software. So it's worth it getting right. Alright, let's open this up. Look at your command line at the bottom of the screen. Click in there. Type units, UNITS. Then hit enter. Actually, you can just type UN and hit enter. AutoCAD figures out what you means. Saves you a 3 whole keystrokes. There it is. The drawing unit dialog box. Now this look like there is a lot going on, but we are just going to go through it piece by piece. It's actually pretty simple once you understand what each part does. There is basically 3 sections we care about: the length, angle, and insertion scale. Let's start with the length because that's most important. Top of the dialog, you see length with a drop down menu. Click on that drop down. You have got 5 options here. I'm going to explain what each one does and when you did use it. First one, architectural. When you pick this, AutoCAD display everything in feet and inches with fractions. You do see something like 10 feet, 6.5 inches. Now here is how it actually works when you are drawing. The base unit, the unit AutoCAD is working in behind the scene, is inches. So if you just type the number 10 and hit enter, AutoCAD reads that as 10 inches. If you want feet, you have to tell it type 10, gets 10 and apostrophe. And how AutoCAD knows you mean 10 feet? You can also mix them together, like type 10 apostrophe and then 6. And AutoCAD reads it as a 10 feet 6 inches. Needs fractions. You can type the same you can see on my screen. Notice the dash before the fraction. That's how you separate it. Now let's try to understand, when would you use architectural? If you are doing any kind of building design in feet and inches, houses, commercial building, interiors, this is what you want. Move to the next one, the decimal. The second option which we have is a decimal. This is straightforward, just a regular decimal number. You type 100.5 and then what you get? 100.5 units. No conversion, no feet, and inches. Just clean decimal value it is showing. Now here is the thing with the decimal mode. The format itself doesn't have any specific unit attached to it. If you are working in millimeter and you type 100, that means 100 millimeter. If you are working in meters and you type 100, that means 100 meters. The numbers is the same, but you decide what it represents based on your project. When would you use decimal? Let's try to understand it also. Like, when would you use a decimal? There is a three situation normally. One, anything metric, like millimeter, meters, doesn't matter. Decimal is a standard for metric work. Number two, mechanical engineering. Even in places that use imperial, a lot of mechanical design is done in a decimal, like inches. Number three, anytime you just want a clean decimal numbers without dealing with feet and inches, conversion. This is probably the most widely used format globally. Now let's try to understand the third option in the length section we have, which is engineering. That gives you feet and decimal inches. Like 10 apostrophe dash will makes a separated 6.5 inches double apostrophe. See the difference. Instead of 6.5 inches, you get 6.5 inches. It works the same as architectural. Base unit is inches. Type 10 apostrophe for 10 feet, but fractions show up as a decimal instead. We have replaced 1 by 2 with the 0.5. Let's try to understand who can use this. Civil engineers, structural engineers, people who need feet for large measurement but want decimal instead of fractions because they are easier to calculate with. If you need to add multiple dimensions, 6.5 is easier to work with than 6.5. Fourth option, fractional. This shows everything as inches with fractions, no feet. So you do see 6.5. Problem is, even a big measurement show up as inches. A 10-foot ball would be 120 inches or some fractions of that. Gets messy pretty fast. Honestly, let's also discuss about where we can use it or when to use these fractions. Honestly, almost never in a modern CAD work. Maybe some woodworking or older drafting standards, but most people use architectural or decimal instead. Now let's talk about the scientific. The last option which we have is a scientific. Scientific notation, it is not that much important, but एक बारी के लिए देख लेते हैं फिर भी कि generally होता क्या है ये. It is not that much important, but let's see once. Let's try to understand it also because it also a part of the units. So let's try to understand it. This is the last option, the scientific notation like 1.55 E plus 02. This is for really specialized work with a huge number or tiny numbers, astrophysics, molecular stuff and kind of thing. For a regular CAD work, you'll never touch this. So here is the quick summary. Architecture in feet and inches. You can use architectural. Anything metric, you can use decimal. For a mechanical work, usually we will use a decimal. Civil or structural. In imperial engineering, we will use engineering or architectural. Always please remember, pick the one that matches your type of work. Now, right below the length drop down, there is another drop down called precision. Please pay attention to this because people get confused about what it does. Precision controls how numbers are displayed on your screen. It does not control the accuracy of your drawing. Let me say that again. This is about display only. AutoCAD always maintain full mathematical precision internally. When you draw a line, the exact coordinates are stored with something like 16 decimal places of accuracy. But if AutoCAD showed up all those decimal places on screen, it would be cluttered mess. You do see like 10.00000000 and 0 everywhere. So precision lets you control the rounding for what you see. The actual geometry stays perfectly accurate in the file. This just control the display. Let's say you are in architectural mode. Click the precision drop down. You'll see option like 0 apostrophe dash 0 double apostrophe. Shows whole feet and whole inches only. And let's suppose to be 0 apostrophe dash 0 1/2 double apostrophe. Rounds in the nearest half inches. Then nearest quarter inch, nearest 1/8 inch, nearest 16th inch, and it goes down 1/32, 1/64 if you need that level of detail. So if you set precision to 1/8, or I can say nearest 1/8 inch, you have dimensions. You have dimension that actually 10 feet, 6 and 3/4 inches. It will display as 10 apostrophe dash 6 3/4 double apostrophe, because that's already an 1/8 inches increment. But if you had something like 10 apostrophe dash 6 and 11 by 16 apostrophe, it would be round the nearest 8th display. So UDC 10 apostrophe dash 6 3/4 double apostrophe. The actual measurement is still in the file. Just the display is rounded. If you are in a decimal mode, the precision options are different. You'll see like 0, whole number only, 0.00, 0.0, 1 decimal place, then 0.00, 2 decimal place, and then 0.000, it is a 3 decimal places, 0.000, 3 decimal places, and so on. Now let's try to understand how do you choose it. Match it to what you are building. For a residential construction, 8 inches or 16 inches is a standard. For mechanical work in millimeter, usually 0, no decimal needed. For work in meters, maybe 0.00, so you can see down in the millimeter. For precision machining, you can take 0.00 or 0.000. It completely depending on your tolerance. And always please remember, you can change this anytime. Your drawing doesn't change just what you see. So pick something reasonable and move on. You are not locked in. Now let's try to understand the another part in the units section, which is an angle setting. Below length, you have got an angle setting. Click that drop down. Most of the time you want decimal degrees. That's just normal angles like 45 degrees, 90 degrees, whatever you are selecting. There is an also degree and minutes and then second. Degree, minutes and then second. Like GPS coordinates, which is normally used in a surveying. Let's try to understand the grades first. The 400 grades in a circle instead of 360 degree. Some European surveying uses this. In radians, mathematical units, unless you are doing something really technical, you won't need this. Surveyors units, bearing format for land surveys and property lines. For most CAD work, stick with the decimal degree. That's enough. Precision for angles, usually 0 or maybe 0.0 is fine. Most angles in drawing are simple, like 90 degree, 45 degrees, that kind of thing. Unless you are doing survey work. Don't overthink the angle settings. Now let's try to understand the another part. The insertion scale. Scroll down a bit, you will see an insertion scale. It says you need to scale inserted content. This setting is really very important. Here is the situation. Let's please look into this. When you insert a block, that's a reusable object. We will cover those later, or when you bring in a drawing someone else made, AutoCAD needs to know how to scale it. Always please remember, AutoCAD files are unitless, as earlier we discussed. If someone draws a door in millimeter and you are working in inches, AutoCAD need to convert it properly. Let's say someone drew a door that's 900 units wide. They mean 900 millimeter. You insert it in your drawing. You are working in inches. If insertion scale isn't set right, AutoCAD just put in 900 units in your inches drawing. So now you have got a 900 inches door that's 75 feet wide. Obviously wrong. That's what insertion scale fixes. Set this to match your working units. Set this to match your working units. Working in millimeter, set to millimeter. Working in, if you are working in inches, set to inches. Working in meters, always set to meters. One thing, if you are using architectural unit, feet and inches, you are actually working in inches as the base unit. So set insertion scale to inches, not feet. Get this right and blocks come in at the correct size automatically. Get it wrong and you'll manually scaling everything, which is again a huge pain. Just match it to your units and you are good. Now let me show you a quick real world setup. I'm doing a house floor plan in a imperial system. Let's type a units, UN or units or UN quickly and then hit enter. I'm hitting an enter. Length, architectural, because I want to work in feet and inches. Precision, I selected 8 inches, 1/8, double apostrophe. Standard for residential framing, which is standard for residential framing. Angle, I have selected decimal degree. Keep it simple. Angle precision, I have selected 0. Whole degree is fine. Insertion scale, I have selected inches. Matching my base unit. Click OK. Done. Now let me test it. I'll type a line command. L. Then hit enter. Click anywhere. Type 10 apostrophe. Hit enter. See, line shows up a 10 apostrophe dash 0 double apostrophe. AutoCAD knows I mean feet. If I type just 18, that's 18 inches. Everything works because I set up correctly from the start. Alright, that's a unit. There is a 3 important thing which always you need to remember and I would like to share with you as well. The first one is, 1. Do this first. Before you draw anything, set your units. Make it a habit. Number 2. Match your industry. Use architectural and imperial buildings. Decimal for metric. Whatever standards in your field, you can use it. 3. The key settings are length type, precision and insertion scale. Get those right and you are good. Now looking ahead. In the next video, we are talking about the drawing limits and template. Basically how to save all these settings so you don't have to do this every time you start a new drawing. But for now, you know how to set up units properly. Open AutoCAD, run that units command, configure it for whatever you are working on and you are ready to start drawing. If you have any question, please leave them in comments. I read all of them. Thanks for watching. See you in the next.